Good afternoon. This is Henk Akkermans and this is Bas Ambachs here. And today we talk about ramp-up issues and product development challenges in the aerospace industry. Bas, welcome.
Thank you.
Once more. You have a long experience and an extensive experience in aerospace manufacturing programs and product development. Could you tell us a bit more about that?
Yes. I've been working at Fokker Aerospace for more than 8 years, and most of the part I've been working in the production facilities in Papendrecht as being responsible as a logistic manager for the whole process of industrialization towards full-blown production.
Stork Aerospace is a supplier to those big integrators such as Airbus and Boeing.
Yes.
One of the very noteworthy programs in that respect from those integrators is the Airbus A380 program. Another one is the Boeing Dreamliner program. Could you tell us a bit more about how these programs fared during their product development and ramp-up phase?
Yeah, well, directly Fokker has been working on the A380 manufacturing the fuselage panels, and for the Dreamliner 787 we have been in contact with Boeing at the beginning phase of the development of this new type of airplane, but of course closely monitoring what is happening in that supply chain, because of the fact that Airbus and Boeing are real hard time competitors. So these two big projects have been on the line every time to see which one has which delay and which is doing better than the other one. But considering the A380, we have been into the development phase, on the early phases already of the design, in which it was very important, of course, to bring a lot of money, because then you could invest into the development of this plane. So it's in this industry almost necessary to do this kind of investments upfront, because otherwise the Airbus itself could not pay for the development of this kind of airplane. And on the other hand, they decided to incorporate 3 new technology, in which one of those was the glare panels, which is a hybrid material between composite and aluminum, which can reduce weight into this airplane, because it's an immense airplane. Every weight reduction is very welcome, and the introduction also of this new technology brings, of course, an extra demand on the supply chain to get it industrialized and get it onto the plane, considering all the quality measurements that are necessary to make it safe. There's one thing that we don't want to see, is that planes fall out of the air. Yeah. And that makes all the quality systems very keen on making sure that new technologies are safe.
So, at a certain moment in time, both programs, the one a bit earlier than the other, ended up in what you could call a crisis. How did that go?
Well, the A380, of course, was in a crisis because of the wiring system. It was developed in 2 different countries, so the airplane was divided in segments, and every segment had to design his own wiring into the wing or into the fuselage. And then at the end of the day, when the final assembly took place, they had to fit, so they had to be connected. Well, at that moment they found out that the developers in Germany worked with a different system, design system, than they worked in France, and this was all due to budgetary cost reductions, that one of the 2 countries didn't upgrade their system to the prescribed system. So the final design ended up in a mismatch of the connectors, because they worked in different systems. So at the final end of the assembly line, when everything already was there to get the plane into the air, they tried to fit these wires into each other and it didn't fit.
So a problem that originated all the way in the beginning of the design phase came to the surface when actually assembly had to start.
Yeah, yeah. So, well, and then from my experience looking at what is happening, of course, in this kind of industry is that we are tending to make more complex, more integrated, more electronic steered devices into these airplanes, and the integration level becomes more complex and complex. And working between 7 different countries that are developing this kind of airplane, the whole configuration management is the basis of your success or not. And also, if you look at the Dreamliner, which is even a bigger crisis than the A380 will ever be, is that they made so great design faults so that the whole plane in itself is not yet applicable to fly. So the whole center wing box, which is the primary function to land, to get all the strength on the landing into this center wing box, was falsely designed. And the other thing that happened was that they designed a complete fuselage in composite, which is very innovative, but they didn't consider all the secondary demands which come off this new design. Already the simple connection methods between aluminum and composite is very difficult, and they underestimated that one. And then at the end of the day, now they even underestimated the way they could repair the plane when it was in operation. So when it's somewhere in the world, it has to be repaired because of a scratch or a damage, and then it's composite. And how do you quickly repair composite? So a lot of big problems in the Dreamliner.
What were the consequences for both Airbus and now Boeing of these crises?
For the A380, I know it cost them around 1 to 2 years delay, and I think in cash flow in billions of euros, which made even these big company AIDS struggling to keep their head above the water. And for the Dreamliner, it's I think the same, but the scenario is even worse because we're now in a financial crisis, so there is a lot of orders are cancelled, and the airplane is not operational. So the A380 is already into the air, it's flying, it's working. Still problems with the wiring, so they solved it, but it was not the reals. They didn't solve the real problem, but they fixed it, and but they're still also behind schedule. So. You could even opt that in the aerospace industry, at the end of the day, nobody makes money, but we'll see about that. Yeah.
So, what did these 2 companies do indeed to fix the problems or solve them?
Well, primarily these big flaws indicate that the whole integration of the supply chain in the beginning of the conceptual phase and the integration of the different segments and configuration management was not in order. So putting that into my perspective at Fokker, where I worked, these things happen over and over again. So the way that we try to eliminate all these risks, they are all these faults are made over and over again. And why is that? Because the design of the airplane is based on load factors, which is based on weight, but also on a time schedule for the first delivery, and that's the whole business case. And in the beginning, we lose a lot of time in getting it right. And at a certain point there is no time in getting it right, and then we have to get to the industrialization phase, and at the end of the day the production has to be done in 1 day. So that's what's happening continuously in this supply chain, and nobody is really rearranging the way how we should work. There is concurrent engineering is a term that is used a lot in this industry, but it is done in the beginning phase, but not in the whole supply chain. So it's still a cascading of different types of moments in the supply chain which hand over their delivery to the next stage. And the whole integration of the production versus the conceptual design is still a long way behind.
Yeah. Yeah, you mentioned this already. In some respects, what are for you the main lessons learned from these big programs and the way that they went so far?
Now, of course, one of the things, because a Dreamliner, it's almost for me incomprehensible what they did wrong, because you have a complete design fault in one of the primary structures. So that is basically how do you call it?
An unsolvable problem.
Yeah, there's an unsolvable problem. So if you then look at the fuselage and the consequence of a composite fuselage, then you could opt for, okay, the process of designing it is of course very difficult, but the industrialization phase should start at the same moment. So at the same moment, people should be very actively already, not only in the thinking process, but in the doing, trying to find out what it does to the production process, what it does to the maintenance process, what it does to the quality systems if you want to get the right approvals for these kind of systems. And I think that normally we tend to take these elements with us in our projects in risks instead of in actions. And so the action would be to start early to learn instead of to mitigate a risk. And so the mindset would be how I can create learning loops earlier in the process instead of mitigating risks. And that's, I think, a different way of thinking, which is not yet landed. And that's also the thing that in Fokker we try to get into place, because one of the problems that we also saw was that when the whole conceptual design phase was done and then we started to industrialize, we found out that it was not manufacturable. And then when it was manufacturable, then we got into the process that the client that ordered the wing part or the complete tail didn't approve the wing because all the quality systems did not fit their requirements. So this was all in the process that the last day of the whole complete 5-year design period was to produce it. You had to solve all these problems in one day. And we didn't start also early in the process to start, for instance, Cessna was a new client for us to make a complete tail. And so we used 2 or 3 years to talk with each other about the design, but we didn't do any production work with each other. So we didn't start, well, you're just going to produce these kind of parts for me so that your operational machine is going to use at our receiving machine. So receiving the parts, validating them, checking you out on the right quality systems, to get that in order, to get that learning already starting at the beginning of the collaboration. And then at the end you have to make up for all the losses you have in the design process. So then everything comes down to that moment. And what then happens is the reaction. And the reaction is that when then the production fails, that the quality systems are even more stringently used to make sure that we don't make any faults. So instead of getting to the problem of the faults, we tend to be more strict in approving the products, so we throw away half of what we produce. So then the pressure of the planning on producing the parts in one day is even more fierce. Yeah. So you get into a whole different loop, which is even bad for the process itself. So that's very, very challenging. I told about the business case, about how it's built up, how the capacity is dedicated to the different phases of the process. And every time it's different, because we know when the shit hits the fan that we need to quadruple our capacity in getting things done. But never, ever, this is taken as a learning lesson in the new project to get this kind of capacity available, because we know it works like this. So we just try to do it over and over again, and we are a very positive industry in that sense, because every new product we think we can do it right.
So the main lessons learned is perhaps that you need to learn lessons from these
Yes,
projects and
yes.
the next one better.
Yeah, but then I think behind that is the way the mind setting in that we need to learn very early in the process. So
Yeah.
from the design principles, as we did some workshops on, we found out that we should not start too quickly by fixing our specifications and starting our design, but just to go slow and to wait until the specifications become more and more clear, and then to speed up. And then in the process of industrialization and operation, you should start with kind of trial production very early in the process to start the learning phase earlier on. And then to combine these different lines in learning in the process and also optimizing your process, so that the design process can learn from the production process and from the production specification quality systems that are asked by the client. And it is like this, because when we had the worst problems about approving products for some customer, I would say, then when they came to our factory, they were like 10 times as critical as they are on their own process.
Yeah.
So when I went to the factory in the US and saw how they made the same products in the same process, and how they approved those products, it's like, this is impossible. But because of the fact that you lose trust in the process at the end of the game, then everything changes, and it makes at the end of the day that the whole collaboration that was starting at the beginning ends in that a lot of people are hurting and making less money, instead of at the beginning trying to cope with these interfaces and trying to find out how can we learn as much as possible to prevent all these mistakes.
Okay. Thank you very much.
You're welcome.